Good morning or afternoon or whatever the time is when you are watching this. I wanted to talk about how we analyze our Vernier graphs, both our position time graphs as well as our velocity time graphs. So first thing I'm going to do is I want to scale our graph. There are two ways you can do this. You can click up on the the minimums and the maximums on the y-axis as well as the x-axis. So I could change this. Notice that my last motion ends around 2 seconds, so I could go ahead and change this to 2. I could change this one maybe to about 1.5. This one, maybe about 0.5 is a good time to start looking at that. That's one option I could do. I'm going to undo all that. The other thing you can try to do is auto scale. So if you press auto scale, that kind of picks what they think looks best for your graph. And that you can see it did a pretty good job up here and down here. You might want to cut off a little time because there was a little bit of motion over here and they thought we might want to see that. We don't want to see it, so I'm going to change this to just 2. Yeah, 2's good. And I'm going to change this to 0.5. Okay, so the next thing we want to do is we want to choose some adequate graphs. The reason I wanted you to do 5 is both to make sure you're getting consistent data, but also so you can kind of pick from the best. So if you look at the just straightness of these lines, or the smoothness, you notice the gold one looks really good, the purple one looks really good, and maybe blue. So what I'm going to do, I'm going to go up to Data. I'm going to delete Data Set, and I want to delete the ones that don't maybe look so great. Green for sure, and red for sure. So to figure out which data set is which, you can actually scroll down here. You'll notice that the latest data table is empty. So I'm going to go over here to run 1. That's my red one. Yes, we want to get rid of run 1. So dataset, delete dataset, run 1. Boom, that's gone. Now we want to get rid of green. Which one was green? Green was run 3. So data, delete dataset, run 3. I'd say these last 3 look pretty good just in terms of their smoothness. What I want to do next is I want to actually see what the slope is. So I'm going to hit, or actually before I get there, I'm going to go to examine first just to show you how this works. It's probably a good idea to put this somewhere that's out of the way. Up here is pretty good. As I drag my cursor along, you'll notice that these numbers up here are updating right here at exactly 1 second. The blue line is at 0.394 meters, and then at 1.5 seconds, the blue line is at 0.985 meters. And by the time we get all the way up here, you'll notice that the blue has reached the floor, which is 1.453 total meters. So it's a good way of just kind of measuring distances, actually, or seeing where the book was at what time and whatnot. We're not going to use that right now. We may or may not use that on later labs. We're going to hit tangent right now. So a tangent line tells you the slope at any point on a line. You'll notice these little black lines that they put on there. That is the tangent. So right here at the bottom of the graph, before there's any motion, those slopes should essentially be 0. So if you take a look at those values right now, I can't really move my cursor very well, right here, if you round, that's pretty much the slope of 0. That means that there's no motion. The textbook is just being held still. Well, as soon as I drop that textbook, now you can see that that slope is increasing. So let's look at actually look at the gold one. I kind of like the gold one. So at this point right here, the slope is at 0.842. I go a little bit further, 1.032. A little bit further, 1.208. So what you'll notice is every time I move this over, the slope is increasing, which means that the speed is increasing. If you look at the units, those units are m over s, meters per second. That's a velocity or a speed. And that keeps on increasing throughout this line until you get right about here. You'll notice that this was 1.318, 1.317, 1.30, 1.316, 1.354. There's some variation there, but what I'm trying to get at is that that slope is largely leveled off. It's not changing anymore. What you should remember is that if you've got a straight line, you've got no change in that slope, that means it's now traveling at a constant pace. What that means is this object, and this is the coffee filter, has reached its terminal velocity. It's no longer speeding up. Now, the way that we're going to I'm going to examine that both on the position time graph, and if I remove our tangent, we're going to look at that on the velocity time graph as well. We haven't really talked about velocity time graphs yet, but what it basically is, if you look at the y-axis, it'll tell you what the speed was at any given time. So the velocity is increasing, it's increasing, it's increasing, it's increasing, and then all of a sudden, right about here on that gold graph, you'll notice that the velocity pretty much levels off. It's a horizontal line. That doesn't mean that the object is stopped. It means that that object is not changing its velocity. It's traveling at a constant velocity now. Well, right here, all of a sudden that velocity drops to 0. That's the point at which, yes, now the book has stopped. Or for the blue one, it stops here. For the purple one, it stops a little bit further on. So as far as analyzing this, what I would say is a horizontal line on the velocity, or a straight line on, which is right here, on the position time graph, tells you that you've reached a constant velocity. In this case, that is the terminal velocity. You can't speed up any more past that line. And it feels pretty good to see that all three of those horizontal lines, or close to horizontal lines, are about at the same value. That means we're reaching the same terminal velocity every time.